Hi everyone. Today, we're diving into the exciting world of GPS with your Arduino MKR board. Specifically, we're looking at the Arduino MKR GPS shield. This shield is fantastic for adding location data to your projects. We'll explore two main ways to connect it. You can attach it directly as a shield, or you can connect it remotely using a cable. Both methods have unique advantages. Let's get started and see how each works. First, let's talk about connecting it as a traditional shield. This is the most common and often the simplest method. You take your Arduino MKR board. Then, you carefully align the pins on the MKR GPS shield with the headers on your MKR board. Ensure that all the pins line up perfectly. Gently press the shield down onto the board. It should fit snugly and securely. This creates a direct electrical and mechanical connection. Your Arduino MKR board will provide power to the GPS shield. It also handles all the data communication automatically. The shield sits right on top of your MKR board. This setup is very compact. It's ideal for projects where space is limited. It keeps your wiring clean and minimal. You don't need any extra jumper wires for power or data transfer. It's a plug-and-play solution in many ways. Remember, a crucial step here is to connect the external GPS antenna. This antenna usually attaches via a small U.FL connector on the shield. Without this antenna, your GPS shield won't be able to receive satellite signals. Therefore, you won't get a GPS fix. This direct shield connection is perfect for integrated designs. It's easy to assemble and reliable. Now, let's move on to connecting the MKR GPS shield by cable. This method offers much more flexibility. Perhaps your project enclosure is too small for the stacked shield. Maybe you need to place the GPS antenna in a very specific location. Or you need to separate the GPS module from other noisy electronics. The cable connection solves these problems. The Arduino MKR GPS shield communicates using the I2C protocol. This means you'll need 4 specific wires for the connection. First, connect the 3.3V pin from your Arduino MKR board to the VCC pin on the GPS shield. Next, connect the GND, ground, pin from your MKR board to the GND pin on the GPS shield. These 2 wires provide power to the shield. Then, connect the SDA, serial data, pin from your MKR board to the SDA pin on the GPS shield. Finally, connect the SCL, serial clock, pin from your MKR board to the SCL pin on the GPS shield. These are your I2C data lines. You can use standard jumper wires for this. Or you can create a custom cable assembly for a more permanent solution. This setup allows you to place the GPS shield a distance away from your main Arduino MKR board. You could place it inches, or even a few feet away. This is incredibly useful for optimizing GPS signal reception. For instance, you could mount the GPS shield and its antenna outside an enclosure, or position it away from interference sources. It gives you greater design freedom for your projects. Always use good quality wires for these connections. Also, try to keep the cable length reasonable. Very long I2C cables can sometimes lead to signal degradation. Always double-check your wiring before powering anything up. Incorrect connections can potentially damage your components. Just like with the shield connection, you must attach the external GPS antenna to the shield. It's still essential for receiving those vital satellite signals. In summary, both methods are effective. The choice depends entirely on your project's specific requirements. The direct shield connection is straightforward, compact, and easy to set up. The cable connection provides valuable flexibility, allowing for remote placement and better antenna positioning. No matter which method you choose, always ensure proper power and data connections. And never forget to connect that external GPS antenna for successful satellite signal acquisition. That wraps up our guide on connecting the Arduino MKR GPS shield. I truly hope this video has been informative and helpful for your Arduino projects. Understanding these connection options empowers you to build more versatile and robust location-aware devices. Thank you so much for watching today. If you found this information useful, please consider giving this video a thumbs up. And don't forget to hit that subscribe button to stay updated with more helpful content like this. Your support helps the channel grow. See you in the next video.